Hi, my name is Abby, and in this video I'm going to be explaining and demonstrating a gas law called Charle's Law. Charle's Law states that the volume of an ideal gas at a constant pressure is directly proportional to the absolute temperature. This means that if the volume of the container increases, then the temperature will also increase. If the volume of the container decreases, then the temperature will also decrease. Here's an example problem to help you understand this a little better. 5 liters of a gas is collected at 100 Kelvin and is allowed to expand to 20 liters. What must the new temperature be in order to maintain the same pressure? Well, the formula for Charle's Law is V1 over T1 equals V2 over T2. V1 and T1 are the starting volume and temperature. V2 and T2 are the final volume and temperature. We can substitute V1 for 5 liters. We can substitute T1 for 100 Kelvin. We can substitute V2 for 20 liters, and T2 is what we are trying to find. Once you substitute, you can solve this by multiplying 20 liters by 100 Kelvin and then dividing that answer by 5 liters, which gives you 400. So the new temperature will be 400 Kelvin. Now, if your question were to ask you for the answer in Celsius, all you would need to do is subtract 273 from 400, which would be 127 degrees Celsius. And if you start out with Celsius in your answer, your question asks for the answer in Kelvin, you just add 273 to whatever it is in Celsius. Now I'm going to show you an example of Charle's Law in action. This is something you can easily do at home. You don't need very many things. You're going to need a candle. It can be a birthday candle, it can be a numbered birthday candle, it can be a regular candle that has glass on the outside, it can be any type of candle that you really want, as long as it fits under the glass that you're going to need, then it should be fine. You're also going to need a plate, preferably one that can hold a little bit of water in the bottom of it without spilling everywhere. And you're going to need a lighter. That didn't work. There we go. You're also going to need water. You can use juice. You can use whatever you want. You can use food coloring in the water so that you can see the experiment better, which I did. What's going to happen in this experiment is when the candle, you're going to light the candle. First, you're going to put a little bit of water in the bottom of the plate. And then you're going to light your candle and put it in the center of the plate with the water. And then you're going to take your glass and put it on top. And when you do that, all the oxygen inside is going to burn up. And then what's happening when the candle's in there is the air inside it is heating up and the volume expands. The volume increases. And when the volume increases, some of the air gets pushed out, hence the bubbles in the experiment. Which I don't know if you'll be able to see very well, but they're there, trust me. And when the candle burns out, then the air inside of the glass cools down, and the pressure on the inside of the glass becomes lower than what's outside in the air surrounding the glass. So the water gets pushed up inside the glass.